My name is James Weaver. I'm a developer advocate with Pivotal, and those are my coordinates. There's my musical blog. It's a musical and technology blog. Please reach out at any point if you'd like to. This is actually going to be talking about NISQ, N-I-S-Q, which means near-term quantum computers. So quantum computers, you know, who's heard about breaking RSA encryption with quantum computers? Okay, so that's going to be maybe a decade or two away. But things that are sooner are things like modeling, being able to model chemical reactions and things. But what I'd like to talk about is music with quantum computers, because music is probabilistic and so are quantum computers. And now this here is Dr. Richard Feynman. Anybody heard of Richard Feynman? He was a pioneer in quantum physics. And he predicted that there would be quantum computers. And anybody recognize this guy? That's Sheldon Cooper with Big Bang Theory. He's giving an homage to Dr. Richard Feynman. He's playing the bongos. Dr. Feynman liked to play the bongos, but he predicted that there would be quantum computers. He said, you know, if you want to be able to model nature, you need to do it quantum mechanically. So the big idea here then is to make a quantum computer compose music. So I've written an app called the Quantum Music Composer app. It works on the cloud-based quantum computers from Rigetti as well as IBM. And the heart of it is a transition matrix. And if you're familiar with music, you know that there are musical notes, C, D, E, and those kinds of musical notes. And when you're composing music, because each style has its own probabilities, a melody then, for a particular melody or a style, you may want a 0.29 probability that it'll go from D to E. Or you may, in a harmony situation, you may want a 1 probability that an F and D are played at the same time, because those are a pleasing combination. So what does quantum have to do with this? Well, we represent all of the notes as quantum states. And as you know, quantum states can be in superpositions. And so what we're going to do then is take those quantum notes and we're going to put them through quantum gates that represent the transition probabilities that we want to have, both melodically and harmonically. And so drilling down a little bit into quantum notes, we can represent notes as quantum states. Here we've got the note C and the note D in a two-dimensional vector space. The C is 1 on the C-axis. The D is 1 on the D-axis there. So they're represented as quantum states. But we also could have a superposition or a combination of C and D, which is neither C nor D, or you could say it's both at the same time if you want to. And the amplitudes there, the root over 1/3 and the root over 2/3, are the amplitude probabilities for if you measure that quantum state that a D will appear or a C will appear. So when the quantum computer composes a melody, it starts out with a C. It puts it through what's called a unitary gate, which has all of those transition probabilities in it, and then it measures it, and maybe because of the amplitude probabilities, probability amplitudes, with probability 1/3 then, it would be measured, it would collapse as a C, or a probability 2/3, it would collapse as a D. And then this is, after a few iterations of that, running that circuit, if we just had C's and D's, that might be a sample melody using the probabilities of quantum computing. So composing a song then, we start out with a melody, and that's a C there on the lower melody. And then we run it through quantum gates, both melodically in the blue there, the U of M, and then also harmonically. And so all of this kind of reminded me of Close Encounters of the Third Kind. It's an old movie in the 70s where, you know, you're playing music with a quantum computer, which kind of looks like that old spaceship. And so I wanted to just give you a taste of what some music that the quantum computer then composed using this application. And if you hit me later, then I will be happy to demo this live to you. But let me just do this right here. If we could turn the sound up. So here's just an example of a composition from a real quantum computer using those probabilities that we put into it. Anyway, that's my talk. Thank you.